Hello, everyone. Good evening. My name is Eon Bakala, and I'm so glad to welcome you all to today's session. So, before we begin, let me take a moment to introduce WTM, Women Take Makers. WTM is a global initiative by Google created to support and empower women in technology. And as part of the initiative, we have been running a very special workshop series called From Design to Market. And so far, we've had an exciting journey together covering a wide range of topics. And to quickly walk you through what we have covered product management, system design and architecture, UX and UI, and front end, back end development. It has been quite a learning journey, and today we're taking it a step further. And we are very honored to have a very special guest with us today, Ziba Atak. Ziba is an AI and ML engineer and data scientist, a Google Women Takemakers ambassador, and also a founding board member of W2D2. And she'll be guiding us through today's session, which is all about the natural language processing, NLP. And please join me in giving a warm welcome to Ziba Atak. Ziba Atak, can you introduce us yourself? And I'm gonna give the stage to you. Thank you.
Thank you so much. Thank you, everybody, for showing up and everybody's note takers for coming to the meeting. It's nice to see so many people. And thank you for the warming welcome. And then I guess let's not make people wait further, and then I'll start sharing my screen and start presenting. All right, so today we are going to talk about some real-world applications of NLP. As introduced, I'm Ziba. I'm a data scientist, AI ML engineer, and I just love NLP because what's better than just using your words to communicate with a computer? So here today we're going to talk about demystifying the real world scenarios and how you would use these NLP algorithms that you would have learned and what that looks like in practical settings. So today I'm going to cover two specific topics, named entity recognition and topic modeling. We're going to look at the different approaches we can take. So these are going to mostly be using pre-trained models, how we can use LLMs to do these tasks, and what it might look like if we were to train these models ourselves. And I'll talk about some industry applications and trade-offs for each of these models. And without further ado, let's start with our first victim, named entity recognition. So just to get everybody on the same page, named entity recognition is a way that you can create some sort of structure from chaos, also known as unstructured text. So what we can use this algorithm for is to get some predefined categories from an existing text. So what can be these categories? Some common ones are people, organization, location, dates, monetary values, products, and depending on how it was trained and what entities were of interest, you will have different categories. Just to walk you through an example, totally a Swiftie, so I'm going to use a sentence focused on Taylor Swift. So let's look at the sentence. Taylor Swift performed a concert at Wembley Stadium in London on August 15th, 2024. When you put this sentence through a named entity recognition algorithm, you will get these labels for certain entities. So it will recognize Taylor Swift as an entity, Wembley Stadium as an entity, and they will have their own labels. So Taylor Swift is a person, the stadium is a location, as well as London, and August 15th, 2024 will be recognized as a date. Now, why would you even want to do all of this? Again, to create some sort of structure so you're extracting information from these texts. Sure, if you have like a couple of documents, you can just do it yourself, but considering the amount of data you will be dealing with in practical settings like corporate settings, they will have a lot of text data. So it's not humanly feasible to just do that yourself. It's also going to help you with searching these documents and information retrieval from those. So if you have an understanding of the entities within the document, it just makes it a little bit easier. And if you're an organizational person, if you're into it, it's always helpful for those. So it creates tags and organizes articles for you. Now that we've kind of covered what it's about, refreshed your memory, hopefully, now we can kind of go onto our notebook. And again, just to repeat myself, we're going to look at how we can use a pre-trained model, how we can do the same thing with an LLM. And I'm going to show you what the data looks like to train it, your own model. I'm not going to attempt training an NAR because it will most likely require some advanced neural networks, which I don't think we have the time for today. So let's start with the pre-trained models. I'm going to use this library called Spacey. Spacey is a great library for some NLP tasks. Here, we're going to specifically focus on the Core Web small model. They have a medium and large, but I'm just going to use the small version for practical reasons. So these models are trained using advanced neural networks, and basically you input your text to the model, it tokenizes it, applies the model, and then you get your entities. Now here I have my self to load our library, and I'm here loading our model, and I have some very, very simple one-sentence text data to get familiar with it. So I have my list, and in this code chunk, what we're doing is selecting each sentence, running it through the model. We're getting the entity label, and familiarize ourselves with the labels. We're getting the label explanations here. Now let's focus on the first example. Apple Inc. is planning to open a new store in London next month. It recognized 3 entities in this sentence, which I believe are the only ones available here. So that's a good sign. Apple Inc. is an organization. You can see the explanation here. It recognizes London as GPE, which means geopolitical entity. So countries, cities, states, that's great. Next month, we have the label date, which is also correct. And if you take a closer look at the other sentences, it's recognizing the entities correctly. Now, these are, as I said, very simple, straightforward sentences that's more commonly used. But what if you have text that's a little bit more tricky? To kind of prove my point, I've went ahead and collected 2 paragraphs from some Wikipedia articles on Scarlet Witch and the Avengers, so MCU characters, just to kind of see what it does with like certain terminologies here. I am doing the same thing, running it through the model. And here, let's look at the entities. It's recognizing Wanda Maximoff as a person, which she is, so that's correct. If you're not familiar with the comic book world, Quicksilver is Wanda's brother. Pietro Maximoff is a person, but it's recognized as a geopolitical entity. And Vision here is also a person, well, sentient robot to be specific, but I don't think they have a category for that, is recognized as an organization. And also, Wiccan is Scarlet Witch's son, is recognized as nationalities or religious or political groups, which is also incorrect. So what this basically tells us that the entities you may have in your documents might require some additional tweaking. So like these pre-trained models might not do the job unless there is like a specifically trained model on these, which I doubt there's a specific one for comics, but in different use cases, that might be the case. Now, one way you can kind of do a workaround with these is using large language models or small language models. And for this use case, we're just going to assume there are no pre-trained medical named entity recognizers. So that doesn't exist in this use case. That's our assumption. So I'm going to use Olama, and Olama is a library that helps you use these open source language models, or a bunch of them on there. I have everything I'm showing in a GitHub repository that I will share at the end with you, so you can find everything there. Also the installation instructions and everything. So we're going to use Llama 3.2 model today. So it's going to run locally, which is great. And I'm going to use the OpenAI's API to communicate with that. And a lot of the large language model libraries use the same structure. So it's a nice thing to know and get familiar with. So here I'm loading our libraries that we're going to use. I'm defining our client and specifying the model that I want to work with. And here, this is kind of more nitty-gritty. It's very, very useful to do stuff. So I'm specifically using the Pydantic library to ensure the data structure. Here, first off, I'm listing the entities that I'm interested in this use case. Like I said, we're going to focus on medical use case. So person, organization, location, date, symptom, diagnosis, medication, dosage, and procedure. These are just the labels that I'm interested in just for this example. And what Pydantic helps us with is enforcing the LLM output structure. As you saw, the output structure from the pre-trained models is quite organized. So you get your entities, your labels, your descriptions. So that's kind of the similar structure that we're going for. And so first of, we're going to define the entity class. So what this is going to give us is the text that it recognizes as an entity, start and end offsets, so the starting character and the ending character index for that entity recognized, and the label for the entity. We're also passing in the descriptions for each of these, just so the LLM has the context for what they mean. And we're going to use this entity class and nest it in the sentence result class. So it's going to give me the sentence that it's working on and the entities from that sentence using this structure here. And we're nesting that in the final class NER results, and it's going to give us the list of sentence results, and it's going to contain all of the entities within that. Now, the system prompt. I've just went ahead and came up with a simple prompt. It's giving basic instructions like you're a skilled medical language processor, you're performing named entity recognition task, and I've given it a few steps to follow. And it's doing, first of all, sentence segmentation, so breaking down the sentences, and it's also going to do co-reference resolution. I wanted to sneak that in here just in case nobody is familiar with that. I'll quickly mention what it is with an example. So think of these two sentences. Iron Man is my favorite superhero. He is so cool. The he here in the second sentence is referring to Iron Man. We know that, but they might not know it, meaning the model. In this case, LLM is good with recognizing that, but I want to kind of dumb it down so it's a little bit more obvious. So once we kind of clean it up a little bit in terms of the co-references, it's doing the entity structure. I'm passing in the labels again, just for fun. And I'm trying to ensure the start and end offsets are correct here. And we'll see how well that works. And here is the sample text that I'm going to pass it in to get the entities. It's just a bunch of names, dates, and organizations, etc. And here I have my function, and I have this decorator here that's coming from the Tenacity library. So what this is going to help us with is if we get an error, so that could be coming from the language model we're using. Maybe I forgot to activate Olama in the background, so it will keep retrying it for 3 attempts, and it will wait 5 seconds in between attempts. So this is usually a good practice to do because API errors can happen if you're using an API. And here I'm just like writing the code to communicate with the client. And this is where we are specifying the output format we want. And I'm keeping the temperature at 0, so it's not taking any creative liberties. I don't want it to get super fun with the results. Now let's look at the results here. So the first sentence is here, and it recognized 3 entities. So the first one is John Doe. It's good. It's a person. Great. Dr. Emily Davis. It's a person. Awesome. Mayo Clinic organization. Great. Now, if you take a closer look at the offsets, it's telling me that John Doe starts at 0, which would be here, right here, this P, which is not John Doe. It's because LLMs are not built for tasks like that. It's mostly going to predict the next token successfully. So you even telling it to do it correctly is not going to be very much helpful. If you really care about the offsets, especially if you're using this to kind of help you with labeling your training data, in case you want to use it for a custom model, it's better to do a function like this to extract the offsets. So here I'm giving the same sentence that I've been talking about, and the entities, it's correctly identifying the start and end offsets. Now, let's say worst case scenario, the LLM didn't do the job. It just didn't work. So you're stuck with training your own model. And I quickly want to show you what your model would look like. Data, sorry, not your model. So I'm using the same sentences that I've showed here. And here we're passing the annotations for this text we're passing in. So it's telling us that 0 to 10 is an organization, which coincides with Apple Inc. And it's telling us that 46 to 52 is a geopolitical entity, which coincides with London, and so on. Now, you've trained your model, but like, how do I evaluate this? So this is pretty much a classic classification task. So we usually care about these 3 metrics: precision, recall, and F1 score. So precision is how much of the entities you predicted are correct. And recall focuses on how much of the entities was I able to find. And the F1 score is the harmonic mean of the 2. So depending on your use case, you might care more about precision or you might care more about recall. So it's usually better to look at all 3 so you get a better sense of what it's really good at picking up. And that brings me to the end of this notebook, and we'll go back to our slide here. And I'm just going to quickly walk you through like an industry application. So think of your e-commerce platforms like Amazon or Etsy. They have a bunch of sellers. They sell a bunch of products. If you try to manage people and try to keep things consistent, it usually doesn't work. There are like a few people who don't use all of the tagging and info that they should provide properly. So if they have a product description, we can use that to our advantage here. That's how named entity recognition is going to be very helpful for us. It will go into the product description. In this case, let's assume this is our product description. It's a handmade ceramic coffee mug from Cozy Clay Co. in a beautiful matte forest green finish. This 12-ounce mug is perfect for your morning brew. You run this sentence, these two sentences through your model, and you should get that the material it's made of, it's handmade, it's ceramic, but it's a coffee mug. It should tell you the brand, it should tell you the color correctly, and it should tell you the size. So when somebody's searching for a matte forest green coffee mug, your product can appear. It's quite helpful for sales, at least. You can also use this for recommendation engines, which is a common use case that I've used it for, especially like in this specific project that I worked on. Imagine a e-learning platform with all of these lectures they have. So recognizing these entities, maybe the subjects covered, etc., is quite helpful when you're trying to recommend what they should watch next. Let's move on to our next and final model we're going to talk about today, which is topic modeling. It's a favorite of mine. It's fun. It's less painful in terms of data because you don't need labeled data here, which is great. So it makes it an unsupervised learning task. But it's a little bit trickier to evaluate. So it's not as clear cut as doing like a loss function or precision recall as we just talked about. Like a use case that this can work for is, imagine you have a lot of reviews left for your products and you want to know what's happening with that. It's not very practical to hire somebody to read through everything and analyze it and synthesize things for you. This is where topic modeling will be very, very handy. It will do that automatically for you. So it helps you understand the main themes from your data set without having to read everything. It helps you organize your content with like tags and categories, again, similar to named entity recognition. And it will also help you discover some trends. Let's say maybe more recent product reviews are talking about a specific product and maybe they're like very, very happy with it. And maybe you want to include that product in a bundle because you've discovered the trend and you might want to bundle it with maybe less of a seller of a product so people can start using that one and see if they like it and want to purchase it again. And now that we're familiar with it, let's jump to our notebook. Here, I'm going to do a similar structure. We're going to work with a pre-trained model. We're going to leverage LLMs for the same thing, and we're going to train our own topic model. And we'll talk about the evaluation throughout. Now, the first one is we're going to use BERT topic. So BERT topic, unlike other topic modeling algorithms like latent Dirichlet allocation, which we'll talk about, that one uses a bag of words approach, and BERT topic takes a little bit of a different attempt to it. So it's using word embeddings. In case nobody's familiar with it, I'll just explain it quickly. So word embeddings are pretty much vector representations of words. So numerical representations. So the computer, your programming language, understands what's going on. So it contains some semantic information. And once these documents are embedded, it goes through a dimensionality reduction algorithm. If you looked at the dimensions of a embedding model, regardless of what it is, especially if it's like a state-of-art model, it usually has a lot of dimensions, over 1,000 in most cases. So working with that many dimensions is computationally expensive. So that's why you normally use dimensionality reduction techniques. So instead of working with thousands, maybe you're reducing it to 100 or 50, whatever is going to work. And then once you reduce the dimensions, you cluster your documents. based with a clustering algorithm. And then once you have your clusters, you look at the topics of that cluster. So here, each document gets assigned one topic. Let's keep that in mind. And now we're going to look at how we can actually use this for our advantage. I'm going to work with a data set from scikit-learn, which is a commonly used machine learning algorithm. The data set name is 20 news groups. And here I'm just defining some of the categories that I want to work with from that data set. So baseball, space, computer graphics, and some religious content, just for fun. Here, now we kind of know the general themes that's occurring within this data. That might not be the case in certain circumstances, but this kind of guides us, especially like if you're looking at product reviews, you have some general categories in mind normally. And here is what our data looks like. So it's like an email format here. It's talking about NASA, military, some space content going on. And now, normally you would clean the data, but with using word embeddings, we don't need to do any of that. Just so you have some variety, I'm using an embedding model from Hugging Face. This is the embedding model we're passing. And I'm also going to use a count vectorizer here. And the reason that I'm doing is to define this n-gram range. So when your data contains phrases like New York, it consists of 2 words. So I want to keep those together. Here, I'm just doing like a 2-word phrases. You can play around with that number depending on what you think your data looks like. And I'm also defining the stop word language as English, so it removes those stop words. And this is applied after clustering, just for FYI. And now we're just plugging everything in. We're specifying our embedding model, vectorizer. And here, I'm passing in 50 as minimum topic size. So what this does is, at least if a topic doesn't exist in at least 50 documents, then we're not going to use it. And we have over 3,700 documents, so 50 is a reasonable number. But if we're not happy with the results, we can play around with the range. And you can set the verbose to true, so you kind of get this pretty output to keep an eye on the progress of your training. And here, this is where we're fitting the model to our documents, and we're getting the topics and the probabilities. This takes a hot minute to run. I think it took me about 6 minutes. So beware when you're training your own. And I ended up with 23 topics here. And I just wanted to look at the first document's probability, which is 1. So it's very, very confident with the topic assigned to that document. And here I want to highlight, so we're just looking at the first 5 topics. Here you see this -1, which is kind of like an outlier, like a catch-all. It doesn't fit anywhere specifically, so it gets dumped over there to the outlier category. As you can see, like the representation, the words don't really mean anything and it repeats a lot. Ax, max, so gibberish. And one way you can visualize your results is a visualization like this. Here, it condenses the dimensions to a 2D representation. So here, if we want to look at topic 0, it highlights it in red. You can see the words and the size. Let's highlight topic 1. So it's hiding over there. Now the clusters look like they're overlapping. They're probably not, because we're reducing the dimensions to 2. If they were in their actual high dimensional environments, they probably would not be that close. So just keep that in mind. Looks can be deceiving. So you can use the slider to highlight the different topics you want to see. And when you hover, it gives you the top words. And in case you think like maybe some categories could be merged, they're just like too similar, you can use your judgment here. But we will talk about some evaluation methods now. One thing you can do if you decide on reducing the number of topics, once you train, you can also use this code here, which I commented out. Here you can pass in the number of topics to reduce topics method in your documents, and you can reduce it to a number you specify. So that's an option you have if you would like to go with that. Now let's talk about some evaluation methods. So one of the evaluation methods we have is something called coherence. So what this basically does is it communicates to us about how coherent the topics are and how much we can interpret it ourselves. So the higher the score, the better. And this model uses different measures. So right now, the one that I'm using does exactly what I just said. So it focuses on topic coherence and interpretability. And there are other measures available. You can just explore the documentation. And what doesn't matter what library you're using, it's usually a good habit to read them so you have a little more of a context. And to use this, I'm just defining the top 10 words as from the topic that I'm interested in. You can play around with the number, reduce it, increase it, whatever you'd like, see what you get. I say always experiment with it. So once we have the top words that we're interested in, we're reutilizing the vectorizer that we've defined prior, and we're then tokenizing the documents using our vectorizer. And once we have the tokenized documents, we're putting them in a dictionary, and that dictionary becomes our corpus. And we're plugging everything in, and then here specifying our measurements and getting our coherence score. So for this model that I trained, we have a coherence score of 0.73. So your coherence score is going to range from 0 to 1. The higher, the better. It means your topics are more coherent. And then the next metric is topic diversity. And the way that you calculate this is dividing the unique number of unique words over the number of topic words you have. So you will get a score ranging from 0 to 1. 1 means every single topic word is unique. 0 means there's nothing unique, it's just all the same. So the higher the diversity score, again, the better. You don't want too many overlapping words across topics. That will usually indicate that you should probably reduce the number of topics you've assigned initially. And we've talked about like probability assigned to documents, and this is a way to kind of get a look at the probability statistics. Here you can, I've went ahead and calculated the mean, median, and the quantiles, and you see the average is 0.79, median is 1, 25th percentile is 0.67, and 75th is 1. So it does seem to be like skewed to the right, so that's negatively skewed. And you can see that here. You have quite a lot of documents that with assigned probability of 1 and some 0. So you might want to reduce this number with tweaking some parameters that we've utilized. So in case this number bothers you, which is 2,000 documents, it's quite a lot. So this is another way that you can evaluate and utilize this knowledge to your advantage. And let's say the pre-trained models is not going to do it for you, and you want to utilize large language models. Here I'm doing the same thing, loading my libraries, client model. Here I have a much simpler data structure that I want to utilize. It's a list of topics, so it's pretty straightforward. Here I'm giving instructions, and I'm using pretty much one-shot prompting, giving it one example so it knows what to do. And again, I'm using the Tenacity library retry decorator to make sure that if it gets an error, we're utilizing it again, running the function again, so until we get the right result, well, within the 3 attempts we've defined here. Here I'm reinforcing the topic results and data structure from the class that we've defined and passing our temperature as 0. And I've just ran one sample document here, and these are the topics that it identified. So Mediterranean, talking about some genocide, conflicts, relations, governments, different nationalities. This does seem like a political document from the first glance. Now you probably don't just want to look at one document. So now I have a function that does it with a series of documents. So you just define your document. So here for testing purposes, I'm just passing in the first 10. And I'm printing the progress here just so you can keep an eye on it. And once I have the list of topics, I am going to create a function that's going to cluster these topics. So you have your individual document topics, and you have your more general clustered themed that may occur across documents. So unlike BERT topic, one document will end up with more than one topic. So I'm giving it instructions here, and I'm using, again, Pydantic to enforce the structure. I'm defining the cluster class. Here, I want it to give me an ID, the name of the cluster, and the keywords that belong to that cluster. And I want it to give it to me in a list. So it will give me each cluster's list separately in one list. And here I'm using the get LLM clusters function to get the clusters, same thing. And let's look at the results. So the first cluster it identified is on computer hardware and technology. The second one is on sports and entertainment. And we ended up with 6. Now, if you look at the words here, it does make sense. It does seem consistent with computer hardware and technology. Although I'm not familiar with everything it's talking about, it does seem like it did a good job there. With sports and entertainment, it looks like the face validity is there. It's doing what it's supposed to do. Same with the third cluster. And when you look at the fourth one, this is where I'm kind of like, I don't think it's quite there yet. This can be improved upon. It's talking about Christmas, Mediterranean, some political stuff that's in there. So it does contain some geography, but it also contains some political topics. So this can be refined. And there's also a political category here, which some of them could have ended up there. So this hints to us that maybe we can improve our prompt and get better results. And in case you decided that you want to train your own topic modeling algorithm, so latent Dirichlet allocation is one of the methods you can use. What it basically does is, so this is a probabilistic model for topic modeling. Like I said, BERT assigns a single topic per document. The core idea of this one is each document is a mix of topics, and each topic is a mix of words. and it kind of follows a back engineering structure. So it starts from the document, finds the topics, finds the words in the topics. And it's an iterative process, so it updates the probabilities of word topic and document topic distributions. And I'm using the same data set to demonstrate it. Here, we're going to do some data cleaning. So we're going to use the NLTK library to remove the stop words for the English language. I'm using the same categories. This is the same data. And here is our pre-processing. So the GenSim library we're using for this already contains a function to kind of do the tokenization, lowercasing, and removing accents. And I've just added the stop word removal process here. And once you run your documents through this, you will get your process docs. And using your process docs, we're utilizing the dictionary function to get our dictionary. And here you see this filter extremes method. So what this does is, if a word appears in less than 20 documents, it gets filtered out. And if a word appears in more than 50% of the documents, that also gets filtered out. So this is a parameter you can play around with to get better results. If a word occurs rarely, it's likely not going to belong to any particular topic. And if it's too common, it's just going to be misleading. And then using your dictionary, you get your corpus. And so this is a little bit different here. So normally, if you don't have the exact number of topics in mind, you would likely explore a range of number of topics. So here I'm defining the range from 2 to 20 with one increment. So it's going to test 2, 3, 4, 5, 2 to 19, all that range. Here, I also want to see to evaluate which one is going to work out the best. I'm going to keep a record of the coherence and the diversity scores. And here I'm printing this, but it's usually to take a look at this in a graph format. So that's exactly what we're going to do. So for this particular model that I trained, this is the result I got. So to interpret this, you would normally use an elbow method. So you would want to see a drastic change. Since these scores, we're not trying to minimize something, we're trying to maximize these scores, you would want to see an upward fluctuation here. And I'm not noticing anything drastic. So it's pretty much along the same lines, although like this is the highest one, this is for coherence, highest diversity, lowest coherence. So this tells me that I should probably tweak a few more parameters. I wouldn't want to use this graph to identify a number of topics that I think we should have here. And here you can use this code chunk to pass in the number of topics that you defined and train your final model and visualize it. And that's the end of this notebook. Now let's take a look at the industry application for topic modeling. For this one, I kind of went with more like an academic theme. Imagine university libraries, they have staff that does research, you have students who do research. So you will have a lot of research articles you will have through your library access. One thing you can do to make this very, very helpful for people who are doing research is doing topic modeling. So you group these articles that belong to particular topics with filters and things like that for easier access. It's more user-friendly, it makes exploring it easier. And even just, you can do something like this for your own articles. If imagine you're writing a thesis, you probably have a lot of articles that you reviewed for your literature review. Now that we've gone through all of that, kind of bringing everything back together, we've explored three different approaches throughout this. Depending on your data availability and your customization, you might want to go with different approaches. So I've kind of provided this breakdown. You would want to consider the cost, the performance, and your use case, and see which approach is going to work better for you. It's usually the upfront cost for training your own model is higher, especially you might need GPUs, and GPUs are not cheap. So considering all of that, I've kind of going to provide you with a framework that you can use. This is probably will get you a long way, but always start with the easiest thing you can do. So pre-trained models are readily available. You don't have to immediately start testing it, but critically think about it. Are there any pre-trained models that are available that would actually help me do the task that I want to do? And if you think it might help you, test it out. It's going to be minimal effort, time, and resources for you, and you can quickly validate it for your use case. See if you like the performance. If you don't, that's when you move on to the next stage and think about, okay, maybe I should try using large or small language models. Probably start with a small language model because you can use Llama, run it locally, so it won't be much of a cost other than for your virtual machine that you're running it on. See if you like the performance. If you don't, then maybe use more of a state-of-the-art, like your OpenAI models or your Geminis and whatnot. If you don't like the performance, then probably training your own is going to be your last resort. And you want to leave this for the last step because it's expensive. You would need a lot of data for good performance. You need a lot of computational resources. So usually leaving this for the last resort is going to be quite helpful for you. And that brings me to the end of my presentation. So thank you so much for listening. You can find me on LinkedIn, and I will share the GitHub repository link in the chat, which also contains the links to the slides. I also have some extra little bits of nuggets for you if you want to explore any additional NLP applications and discover some resources and some production tips. And now I will stop sharing and take any questions you may have.
Thank you so much, Ziba. It was such an insightful session. We had a wonderful time.
I'm glad. Hope you're not sick of my voice.
No, it was really amazing. Thank you so much.
Thank you for having me. Yeah, I'll share the GitHub repository, which is public, so you can access it.
Okay.
In the chat. And I'll also share it with you, so when you post a recording, you can put it in the description.
Okay, thank you. So we have a couple of questions.
All right.
So the first question is, as a Google Women TakeMakers ambassador and a founding board member of W2D2, you've been actively involved in building communities. What role has community played in your personal and professional growth?
Community has been very, very helpful for me. Working in the industry, you come across different situations, different tricky scenarios. So it's helpful from a technical standpoint, but you most of the time end up needing some emotional support and some sort of guidance. So having those people around you is very, very helpful, who's most likely gone through some things, and they can give you a lot of advice on how to navigate those tricky situations. Especially as women, we experience some things that other groups may not experience. So having that insight and seeing how others have walked through that path is quite insightful and inspiring. So it's mostly my support group, but I also learn a lot from other professionals. And it's also, really helpful, especially if you're doing some job applications and if you're looking for a new job, having that network becomes very, very handy during those times, especially.
Thank you. So the second question is, what challenge have you faced as a woman in tech, particularly in such a specialized field as AI and ML, and how did you overcome that?
Um, it takes a lot of patience in most cases, which is not my strongest suit. So it's a lot of deep breathing for me. You come across some mansplaining situations. It happens quite a lot, more than I care to admit, to be honest. Other challenges is sometimes I feel like people don't hear me when I say things, and then they repeat my ideas back to me, which happens. Um, so it's like tricky to navigate those situations because you get emotionally triggered because you care about your work. And one of the things, like deep breathing, so taking a moment to kind of center yourself, is very helpful for those moments. And kind of like, hey, yeah, I mentioned that. Thank you for bringing it up again. So kind of learning that corporate lingo to navigate those situations. That's what I use my network for. Some people have more experience with that.
So the third question is for those in the audience who want to pursue a career in AI and ML. What advice would you give, both in terms of technical skills and mindset?
Your mindset is going to need to focus on growth. The thing about this work is it doesn't matter how much learning you do, the learning never stops. I'm still learning to this day. So upskilling is like a constant thing that you're going to need to do. There's no end to it. Every day something new comes out, especially if you're working with large language models. Something new comes out every single time I open LinkedIn. I see something new. So it's a lot to keep up with. So brace yourselves, but don't give up on it. Just have a really nice schedule for yourself to take some time to do learning. You don't have to learn it all at once. It's not going to be possible. Technical skills learning is, it's going to require a lot of practice. So get your hands dirty. Don't expect things to be perfect. Even like it took me a while to put all of this together. It took me a few tries to make it all make sense. So it's going to take some time and you're going to make some mistakes along the way, but that's going to be your best teacher. So that growth mindset is going to become very handy. And the industry's state is overall, just the job market is quite difficult, I believe, globally. So it's not you. And I have to say that to myself too.
Okay, so lastly, if you could go back and give your younger self one piece of advice at the start of your career, what would it be?
My career path is not very traditional. So I actually have a psychology background. And I've done a master's on it and I've done my MBA. And that's where I've confessed my feelings for the data world because I always enjoyed working with data. And that's when I was like, okay, I'm going to bite the bullet. I'm going to learn programming, whatever that may be, and learn how to do this for a living because it's fun. So can you repeat the question again?
Okay, no problem. So if you
Oh,
so if you
advice
could
to
go
my
back,
younger self.
yeah,
Yes. So pay
yeah, yeah.
attention would be one. but just kind of sometimes I find myself thinking that maybe I should have learned about this field when I started out, but also it's okay to figure things out later in life. Like it had to be trial and error for me. Like I always liked psychology and I still bring it to my work to this day, especially working with people, but I also find it very helpful for working with data as well. So making mistakes is okay. Try and error would be one thing, because I decided that, okay, this is what I want to do. I didn't look at anything else, just stuck to that path. And then I started doing it. And it's like, okay, this doesn't feel right. So maybe explore things would be a better advice for me, to then just like pick one thing and then just work really hard on it.
Okay, thank you so much. I have my co-host with me, Ruth. If you wanna say something, I would uh, give the stage to you.
Uh, am I audible? Can
Yes,
everyone hear me?
yes.
Okay. Thank you, Ziba. It was such an incredible session. It was so inspirational, especially for the Q&A session. It was inspirational, to be honest. So thank you, Ziba, for taking your time to craft such incredible PowerPoint and session. And thank you, everyone, for joining. Um, so other than that, I want, yeah, I want to say, so you could follow us on all our social media accounts. I have put the link on the chat. Yeah, would be all from my side. Thank you, Zion.
Okay, thank you, Ruth. So it was such an incredible session and a wonderful session. Thank you so much, Ziba.
Abigail, Abigail has raised her hand. You can
Okay.
unmute yourself. Yeah.
I'm sorry. I had a quick question. Thank you so much, Ziba. It was an amazing session. You're so sweet.
Oh,
We
thank
can
you.
tell your personality and very engaging. I was smiling the whole time, and
I'm glad. I
we're not.
wanted to make it fun.
Yes, we were not tired of you. That's for sure. You were so sweet. So I wanted to take the chance to ask you about. You were talking how you transitions from psychology to this data scientist and this field. And so, for people that are on the same journey as you, I hope there are people, or maybe the people might be me, but hoping there are other people. How was the transition, and what would you give us on that path?
Um, I struggled with kind of how much I had to learn. I was like always good with statistics. You learn a lot of that during your psychology degrees, but the programming and learning all of the different training methods and everything, all of the different fields, it was quite overwhelming. And I didn't know I should have picked the specialization that I wanted to go with. At the time, I was very consumed with trying to learn as much as I could. I didn't really have a direction. And at the time, I didn't really have a mentor that I could talk to about it. So I really encourage that you utilize these communities like Women Tech Makers Ethiopia, or I'm also part of a community founder of Women Who Do Data. We also have quite a few women tech makers there. So utilizing those communities to kind of have people around you who has more experience that can guide you through those transitions, especially if you have a specific area that you want to go into, you should most likely pursue that. Because there are a lot of things you can focus on, like NLP is one thing. You can mostly focus on classic machine learning, or you can focus on computer vision. There's a lot you can do. And every day the demands on roles like data scientist, machine learning engineer, it gets more intense. I would very, very much encourage you to keep a tab on what are the skills required in those job descriptions that you might be interested in, so you have an understanding of the industry demands. I wish I'd done that more when I was trying to transition, because I found myself caught off guard, especially with, I was mostly interested in data scientist roles, but most of the data scientist roles require some machine learning engineering skills. So some back-end knowledge, like production, deploying your models, that is very useful. So I had to kind of scramble and try to figure it out as I was on the job hunt. So I wish I would have done that more when I was transitioning. So those would be my top tips.
Okay, thank you so much. Thank you.
Of course.
Thank you so much for your time, Ziba. We had an amazing time. It was a wonderful presentation. Thank you so much.
Thank you so much for having me.
Thanks. That'd be all. So, Ziba, we'll let you go now. Thank you again so much.
Thank you. All right. Nice to see everybody. You can find me on LinkedIn. Come bother me all you want. We can chat there. All right. Bye, everyone.
Yes. Bye.
Bye.